everyone, welcome to our GRE training series. My name is Eliandi. I'm a GRE trainer here at the International Scholars Program. So today we'll be looking at arithmetic in the GRE. Specifically, we'll be looking at exponents and roots and how the GRE tests these concepts in its quant section. So welcome and let's begin. So we'll first start by looking at exponents and their rules. So conceptually, when you are dealing with an exponent, you know that you are basically dealing with a number multiplied by itself several times. So for example, when we have 10 raised to power 3, we are just multiplying 10 by itself 3 times. Okay, but this is the basic understanding of exponents or powers, as some people call them. Powers or exponents. But working out these questions, multiplication by multiplication, is not always the most straightforward way to go about exponent questions. And that is why mathematics has given us some rules that we can use. These rules or laws are basically shortcuts that can help us do these questions within the shortest time possible, which is crucial because for the GRE, time is of the essence. So for example, one rule we have is that a raised to power m times a raised to power n is just the same as a raised to m plus n. So that when you have a number like 10 cubed times 10 squared, then this is just the same as 10 power 3 plus 2, which of course is 10 power 5. So take your time to understand these laws, if you are preparing for the GRE test. These are things that you should have at your fingertips. You should not have to pause and think about them. The understanding these laws and rules will make your work easier. Look at rule 8, for example, that a raised to mn is basically the nth root of a raised to power m. So that when you have something like 8 raised to power 2 over 3, then you are dealing with the third root of 8 squared, where 3 is our n and 2 is our m. And the cube root of 8, of course, is 2, because 2 times 2 times 2 will give us 8. So this is the same as 2 squared, which is of course 4. So having this at your fingertips is something you need to really consider if you are preparing for the GRE. Now, let's look at some of the ways in which the GRE tests this question. So we have here a number n is equal to 9 times 27 times 243 times 729. Which of the following options are true? This is a relatively simple question if you understand the concept of exponent or powers. So we have n, 9 times 27 times 243 times 729. Let's try to represent this number in one base raised to a specific power. That would be easier than, for example, multiplying everything out and then comparing with the answers. So we have n as 9 is 3 squared. Let's see if we can put them all in base 3. Then, of course, 27 is 3 raised to power 3. 243 will be 3 raised to power 5. And 729 will be 3 raised to power 6. So remember what we said, that a m times an will be am plus n. So in this case, our n will be 3 raised to 2 plus 3 plus 5 plus 6, which gives us, this is 5, 10, 16. So saying that n is equal to all this is the same as saying n is 3 power 16. So what do you think we can do next? Well, the remaining bit is just to compare the answer choices with 3 power 16 and see which one fits. So of course, the first one you can see straight away, no further manipulation is needed. A is an answer, so let's check the rest. For B, we have n being P times Q, and we are told that P is this, Q is this, so our n will be 918 times, 98 to 9 power 8, which is 9 power 16. 9 power 16 is not the same as 3 power 16. So that is out. Let's look at C. C is 9 to power 16, just like B. So that is also out. Then D we have that n is 9 to power 8. So I want to compare this 3 to power 16 and 9 to power 18 and see if they are equal. So let's see. We have 3 power 16, which we have confirmed to be the answer. Let's compare it to 9 power 8. Okay, so we can either make 3 power 16 have a base of 9, or you can make 9 power 8 have a base of 3. So from this point, you can follow whichever path looks best for you. So for me, I'll go with 3 power 16. Then I need to make 9 power 8 have a base of 3. So 9, if you are looking at it in terms of base 3, will be 3 squared. Then we still have our 8 here. And remember, we can multiply this so that we have 3 power 16. So again, D is another answer. So our answers for these questions are A and D. Now, remember, for the GRE, there is no partial credit. There is no partial credit. That is, for a question with multiple answers, you have to get all correct to get full marks for that question. So for example, for this question, if you get A but miss D, that is a 0. So keep that in mind, no partial credit. Now, let's look at the concept of cyclicity, which again is one of the ways in which the GRE tests exponents and its understanding. So what is cyclicity? Now, basically cyclicity is the pattern we get when we raise a number to its successive powers. The pattern basically looks at the last digit. So when you raise a number to successive powers starting with 1, is there a pattern that you get when the last digits are compared? So for example, let's look at 2. 2, sorry, we said we start with power 1. So let's see. 2 power 1 will give you 2. 2 power 2 will give you 4. 2 power 3 will give you 8. 2 power 4 will give you 16. 2 power 5 will give you 32. 2 power 6 will give you 64. 2 power 7 will give you 128. And 2 power 8 will give you 256. Now we said cyclicity depends on the pattern when you compare the unit digits or the last digits. So let's see, 2, 4, 8, 6, 2, 4, 8, 6. There's a pattern, you can see that, right? So after 4 successive powers, we get the same numbers again. 1, 2, 3, 4. 1, 2, 3, 4. So we say that 2 has a cyclicity of 4. Now, understanding this is very crucial when dealing with the arithmetic operations involving unit or last digits. Because for many of these operations, the last digit basically depends on the unit digit or last digits of the numbers involved in the operations. So what am I saying here? For example, when you have 23 multiplied by something like 921, the unit digit of this operation will depend only on the unit digit of the individual numbers, right? So that the unit digit of this whole thing will be the same as 3 times 1. That is, when you work out this question, you will get that the unit digit or the last digit will be 3. Incidentally, when you multiply this, you will get it as 21,183. So that is why this concept of cyclicity when dealing with unit digit questions is crucial. So again, let's see how the GRE tests this concept.
You are watching Success with Bob Mwiti Show, presented to you by the International Scholars Program. The International Scholars Program is an award-winning international education financing scheme that helps bright students to pursue graduate studies abroad regardless of their financial background. You can find our programs by going to www.internationalscholarsprogram.com. The International Scholars Program, empowering dreams.
So we have here, what is the unit digits of the product of 32 raised to power 28, 33 raised to power 47, and 37 raised to power 19? As you can guess, if you don't have a scientific calculator, which you won't have in the GRE, this can be a tough nut to crack. But we can deploy our understanding of cyclicity to work it out in a very short time. Now, we said that in some operations which include this, the last digit, which is what the question is asking for, will depend only on the last digit of the individual numbers. Like for this question, the unit digit of the product will depend on the unit digit of the individual numbers. That is, the unit digit of this question will depend on 2 power 28, 3 power 47, and 7 power 19. Because the last digit of 32 raised to power 28 will be the same as the last digit of 2 raised to power 28. So let's see. The first thing here is to determine the cyclicity, and then I will explain using this example how the knowledge of cyclicity helps you get the unit digit. So let's determine the cyclicity of 2. We have 2 power 1 as 2, 2 squared as 4. Here is 8, 16. Okay, so we stop there because we have the pattern already, 1, 2, 3, 4. So cyclicity is 4. So the next step here, take the exponent, divide with the cyclicity, and determine the remainder. This is what we want. This is the interest, where our interest is. So for our case, we have the exponent is 28, divided by cyclicity of 4, we have 7, remainder 0. So the remainder is 0. Now, how does this help us? Come back to the question. If the remainder is 1, then the last digit is this. If the remainder is 2, then the last digit is 4. If the remainder is 3, then the last digit is 8. If the remainder is 0, or if there is no remainder, then the last digit is 6. So in our case, the remainder is 0, so the last digit is 6. So 32 power 28 has a unit digit of 6. Let's look at 37 to further help you understand that concept. So in this case, we look at the cyclicity of 3, 3 power 1, 3 squared. Here we have 27. By the way, you don't have to work out everything here. Just consider the last digit. Like in this case, even the multiplication, you don't have to multiply 27 times 3 here. Just consider 7. 7 times 3 will give you 21 because the interest is in the unit digit. Then 3 power 5 will give us 3 as the last digit. So again, the cyclicity is 4. 1, 2, 3, 4. So exponent divided by cyclicity, we have 11, remainder 3. So remainder 1, remainder 2, remainder 3. That means 33 raised to power 47 will give us a unit digit of 7. So let's go to the last one. 7 power 19. So cyclicity of 7, we have 7. I remember I've said we are only dealing with the last digit. So this will be 49. This will give us 63. The last digit. This will give us 21. This will give us 7. So we stop. 1, 2, 3, 4. The cyclicity is 4. So exponent divided by cyclicity, that will give us a remainder of 3, because that would be 16, remainder 3. So remainder 1, remainder 2, remainder 3, we have 3 as the unit digit of 37 to power 19. So the unit digit of this product will be the same as the unit digit of 6 times 7 times 3, which is 42 times 3, which is 126. So the last digit of this whole thing is 6, and our answer is D. Now, let's have a brief look at roots. When we are dealing with roots, maybe the first concept we need to know is that a root is just a fractional exponent. Yes? When you have the square root of x, you are basically saying that you are raising x to power a half. When you have the cube root of the cube root of x, you are just saying that you are raising x to power a third. So actually, if you understand exponents or powers, then you are also good with roots. Just one thing you need to note here. The GRE has adopted some mathematical concepts that are not universal. For example, when the GRE writes the even root of a positive number, then only the positive solution is considered. We know mathematically that the square root of 4 can be positive 2 or negative 2. But in the GRE, if you have positive 4 square root, we only consider positive 2. So keep that in mind. But this only applies for even roots. If you are dealing with an odd root, like for example, the cube root of 8, then in this case, you should consider both values. Like in this case, the cube root of 8 is 2, but the cube root of negative 8 will be negative 2. So for odd roots, the solution will take the sign as of the base. So if it was positive, the cube root will be positive. It was negative, the cube root will be negative. So that is just one thing to note here as a convention that GRE has adopted. But in many cases, the rules that apply for roots apply for exponents. Now, let's look at some of the ways in which the GRE tests roots and its understanding. So we have this example here. The task is to determine an equivalent from the answer choices. Now this, you have to simplify the question so that you can compare it directly to the answer choices. For this type of questions, there are no specific rules that you should follow. As long as what you are doing makes mathematical sense, that is, you don't break any rule of math, then you are good. So let's see. We have in square root of 20 plus root 80. So the task here is to find the square root if possible, or simplify it as much as possible. Here, we can simplify 20 as 4 times 5. Or maybe we can start with the other part of the equation. So we can have 80 as 16 times 5. I've picked 16 because I want to simplify this question, which means I want a number with a perfect square so that I can take it out of the square root. So this will give us 20 plus 4 because that's the square root of 16. Then 5. You should not forget about this. Now here, you can see that there is a common term. 4 is common for both of these terms. So we can have maybe another way to look at it to make it simpler. We can have 4 times 5 plus 4 root 5, all this under this square root. And then we can factor out 4 here so that we remain with 5 plus root 5. And then, of course, 4 will give us 2 when we find its square root. So that we end up with 2 square root of, let me write this in a better way, 5 plus root 5. So if we are to have our answers in this form, then this is how far we can go with the simplification, and we end up with choice D. Let's look at our last example for the day. So in this case, we have the square root of the square root of the square root of 3x equated to the fourth root of 2x. The question is asking, what is the greatest possible value of x? So let's see if we can find the value of x. Remember, we said that a radical, like a square root or a third root, is just an exponent in another way. Okay, so like square, finding the square root of a number is the same as raising it to power a half. So you can say that 3x, the square root of it, is the same as 3x raised to power a half. Then we have the other half for this second one, and the third one for the third case. And this is equated to 2x. Fourth root means raised to a quarter. So remembering your rules of exponents, you can multiply all these to have 3x raised to power 1/8 equal to 2x raised to a quarter. Now we have an equality sign here, which means whatever we do to one side, we must do to the other. So I'm looking for a way to simplify 3x raised to power 1/8 or 2x raised to power quarter, especially if you can get rid of the exponents. So I can say, for example, that 3x raised to power 8, 1 over 8, I can multiply it by, I can raise the whole thing, can raise the whole thing to power 8 to get rid of the exponent. Then the same thing I must do to the other side. Remember, in maths, in equations, whatever you do on one side, on the left-hand side, you do on the right-hand side. So here, I will have 3x raised to power 1 equal to, here we'll have 2x squared. So that we have 3x is equal to 4x squared, or 3x minus 4x squared is 0. And we have the good old-fashioned quadratic equation here. So we can factor out x, 3 minus 4x as 0. So one of the solutions for this is that x is 0, but that is not the only one. If you consider the bracket, we'll have 3 minus 4x being 0, minus 4x being negative 3. That is if we subtract 3 from both sides. Or we can say x is minus 3 over negative 4, which is 3 over 4. So we have two values of x. X can be 0 or 3/4. But our question was asking for the greatest possible value. So of course that is 3 over 4. So that brings us to the end of our arithmetic, roots, and exponents questions. I hope you've learned something. Bye and welcome next time.